Everybody, we're going to come back for one more video where we're looking at the position over time graph and velocity over time graph for a cart moving back towards a reference point. We looked at only the position over time graph earlier, and we saw that the slope decreased as we basically decreased our distance as time moved on. Now we're going to look at the velocity graph and see how that relates. Okay, all right. So again, we have some static kind of on both ends, okay? Here is before I pushed it, okay, where it's not moving, okay, it's staying at a constant position. Right here, you see a little static on that velocity graph, but essentially it's staying right here at zero velocity. Then I pushed it, and you see that constant negative slope, which is what we would expect from a position over time graph. Down here is our velocity graph, and what you see is, again, a constant flat line, okay? Maybe got a slight slope to it, but that's because it wasn't perfectly a constant speed. It actually slowed down just a little bit as it moved, okay? But what you end up seeing here is a constant negative velocity. This is actually the x-intercept right up here. So this is actually below the x-axis, so it's showing a negative value. Okay, so a negative slope or a negative constant velocity just means that it's going at a constant speed, but it has a negative speed. The reason it has a negative speed is because it has a negative change in distance, okay? It's getting closer, okay? So this is going to be a negative number here. It's a really hard thing to understand. Basically, because the distance is getting smaller instead of bigger, you're having a negative velocity instead of a positive velocity. The only difference between a positive velocity and a negative velocity is the direction of travel. You're moving away with positive velocity. You're moving toward your reference point with negative velocity. And then right here, that's just, again, it hit the end and it was still collecting data. Okay, so really that's not showing anything. The important part, the negative velocity right here, that's where it's moving back toward the reference point at a fairly constant speed.